In this video, I am going to explain the different problems involved in metal cutting. Now let us first see the problem. The following data related to orthogonal cutting process. The depth of cut is given 0.35 mm, chip thickness 0.95 mm, width of cut 2.8 mm, tool rake angle 12 degrees, tangential force or cutting force that 1000 newtons, feed force 500 newtons, spindle speed 60 rpm, diameter of the workpiece 60 mm, the maximum power available at the machine spindle is 4 kilowatts. The power required 0.1 kilowatts for centimeter cube per minute. So what we are going to find out, calculate the following. The coefficient of friction between the tool and the chip, ultimate shear stress of the work material, chip thickness ratio, length of the chip removed in 1 minute, shear angle, friction angle, shear strain, maximum metal removal rate. This is the problem is given. So before going to solve any problem, this is the fundamental rule follow so that there is no mistakes while solving the problem. So first of all, you can understand while reading the problem what is problem is given. You can understand thoroughly. Then you have to write. First, we have to write given data. So whatever the data is available in the problem, that given data you have to write first. Then what you are going to determine to be found, you can write. Then you have to start the solution. So in these three stages, there is no mistakes. Sometimes what happened, some of the parameters we are missing without calculating overlook, it may be possible. Okay, that's why you have to follow this pattern so that without any missing of any parameters or any data, you can solve each and every item. So after end of the problem, once again you can cross check all the points are involved or not, all the whatever the determinations are asked in the problem, all are solved or not. That you can check finally. Okay. Now let us say that first I have to write given data. Okay. Now this given data is written. So the depth of cut T is equal to 0.35 mm and chip thickness TC is equal to 0.95 mm. Width of cut B is equal to 2.8 mm and tool rake angle alpha is equal to 12 degrees and tangential force, that is Ft, is equal to 1000 newtons. Feed rate FF is equal to 500 newtons and spindle speed N is equal to 60 rpm and diameter of the workpiece that is given 60 mm. So this is the data is given. Okay, once the given data is written here, so it's easy, you can solve the problem. Now next what we are going to find out, that is the to be found. To be found I have to write here. Okay, now the first one is coefficient of friction between the tool and chip, that you are going to determine. Next is the ultimate shear stress of the work material, then chip thickness ratio, then I have to find out the chip thickness ratio. Then D is the length of the chip removed in 1 minute and next is the shear angle, next is the friction angle and shear strain, maximum metal removal rate. So these are the items you are going to find out from the given data. Okay, now you can clearly understand what is the data is given and what we are going to find out. Next we are coming to the solution. While doing the solution one by one from the A to H, you have to calculate. Now let us see that how we are going to find out the solution for this problem. So first solution, the first one is asking coefficient of friction between the tool and chip. The mu, the coefficient of friction is the mu, you are going to find out. So what is the formula? The mu you are going to find out. So the formula is the frictional force plus tangential force into tan alpha divided by the tangential force minus frictional force into tan alpha. Here you can find out because that frictional force is given, tangential force is given and tool rake angle alpha is given. So you have to find out mu, substitute all the data, then you can obtain in this equation. Then you have to find out the mu value. So the mu value is obtained 0.797. So the coefficient of friction between the tool and chip, using this formula you can find out mu value. Okay, now the first bit A is over. Next, coming to the second bit, that is the ultimate shear stress of the work material. So how we are going to find out the ultimate shear stress of the work material? What are the formulas are available? First you have to think about. So the ultimate shear stress I want to find out. So we know that ultimate shear stress is equal to shear force by shear area. Shear force by shear area. How we are going to find out the area of the shear plane? That is the cross sectional area of the uncut chip divided by sine pi. Cross sectional area of uncut chip divided by sine pi. What is the phi? That is the shear plane angle. So now here, you can find out the ultimate shear stress, that is equal to shear force divided by area. So here area is A by sine pi. So now you can obtain this formula, that is the ultimate shear stress tau is equal to that shear force Fs and sine pi divided by A. So once if you know these three quantities, then you can find out ultimate shear stress. Okay. Now first you have to find out these three parameters. Then you can substitute in this equation. Then you can obtain the shear stress. Now let us see that the Fs is equal to shear force. So you can find out the shear force. Use this equation and you can find out the shear force. What is the equation? Fs is equal to Ft into cos pi minus Ff into sin phi. So always you can practice. Once if you know the equation also, directly don't substitute the data. First you have to write the formula, then you can substitute the data so that there is no error will occur. You can practice this way. So in this equation, that is the shear force we need to calculate means I required tangential force and the frictional force and the shear plane angle pi. But shear plane angle pi is unknown. So first to find out the shear force, shear plane angle, that pi is equal to shear angle, that you are going to find out. How you are going to find out the shear angle? Shear angle or shear plane angle both are same. So that how you are going to find out? That formula is pi is equal to tan inverse r cos alpha by 1 minus r sin alpha. Again here this r term is unknown. So what is the r term? That is the chip thickness ratio. That is also not given. So before going to find out the shear plane angle, first find out the chip thickness ratio. So you can find out the chip thickness ratio. R is equal to chip thickness. How you are going to find out the chip thickness ratio? That is equal to depth of cut. This R is equal to depth of cut divided by chip thickness. So depth of cut is given in the problem, that is 0.35 and the chip thickness is 0.95. Now you can obtain this R value is 0.368. So that is the chip thickness ratio is obtained. So now the chip thickness ratio is obtained. Alpha is the rake angle. Okay. Now you can substitute the data in this formula. Then you can find out the shear plane angle. Now let us do it. So you can find out the shear angle pi is equal to, substitute all the data in this equation, then you can obtain the shear angle, that is the 14.5 degrees, that is the shear plane angle. So once the shear plane angle is obtained, then you can substitute this data in the equation, that is the shear force. The shear force Fs is equal to 1000 into cos 14.5 minus 500 into sin 14.5. Now simplify, you can obtain the shear force, that is 1112.36 newtons, that is the shear force. So now once the shear force is known, then you can find out the ultimate shear stress. Therefore the ultimate shear stress, that B parameter you are going to determine, that is obtained. Tau is equal to the shear force, that is 1112.36 into sine, the friction angle is the shear plane angle is pi 14.5 is obtained, divided by the area, that is 2.8 into 0.35. Then you can simplify, you can obtain the ultimate shear stress. You can obtain ultimate shear stress, this value, that is 1061.16 Newton for mm square. That is the ultimate shear stress. Okay, next the D parameter, length of the chip removed in 1 minute. You are going to find out how much length of the chip removed in 1 minute. So we know that the cutting ratio R is equal to length of the chip removed divided by uncut chip length. Length of the chip removed divided by uncut chip length. That is the cutting ratio. So we know the uncut chip length. You can find out the uncut chip length by using this formula, that is the pi dn, that is equal to pi into 60 into 60. You can simplify, you can obtain 11,309.7 mm per minute. That is the uncut chip length. Okay. So and also we already calculated the cutting ratio. So using this above formula, cutting ratio is equal to length of the chip removed by uncut chip length. From this you can find out the length of the chip removed is equal to cutting ratio into uncut chip length. Now you can use this, you can find out the length of the chip removed, that is obtained this value 4161.97 mm per minute. So that is the D bit. Next F, friction angle. You are going to find out the friction angle. We know the formula mu is equal to tan beta. We know the formula mu is equal to tan beta. Okay. So now already the mu is known. So then you can find out the beta. So the beta is equal to tan inverse of mu. Mu is 0.797. Now we can obtain this beta, that is the friction angle, is obtained 38.5 degrees. That is the friction angle. So that is the F. So next what we are going to find out, shear strain. So what is the formula to determine the shear strain? We know that the shear strain, the epsilon is equal to cot pi minus tan pi minus alpha. So phi is the shear plane angle, alpha is the rake angle. So both are known. You can substitute, you can obtain the shear strain. So the epsilon is equal to cot 14.5 degrees plus tan 14.5 minus 12. Then you can obtain this is the value 1.13. That is the shear strain. Next, maximum metal removal rate. How you can find out the maximum metal removal rate? What is the formula? So the maximum metal removal rate is obtained once if you know maximum power available divided by power required. So MRR, that is equal to 4 by 0.1. So that is equal to 40 centimeter cube per minute. Okay. So now you have calculated all the parameters. Okay. Now I think all of you understand how you can solve the problem. So once again, just I'm repeating. So any problem, first you have to prepare what is the given data and what you are going to determine. Then you can start the solution, so that you can each and every parameter you are going to solve without any mistake. Okay. So now we'll see that next another problem in the next video.